Hey, today we're going to talk about 7.6, Reduction of Air Pollutants. So take a moment, check out the Enduring Understanding, look at the learning objectives, pause the video, review the essential knowledge, and set up your Cornell notes. So there's a few different ways that we can reduce our air pollutants. One method of reduction is regulatory practices. In other words, government mandates. The government mandates on the production and emission of these air pollutants. So some of the ways that that the government has done this is from the Clean Air Act of 1970, from pollution credits, and putting a standard on the corporate average fuel economy, the CAFE. This is basically a guidance for how many miles per gallon your car should receive. And the Clean Air Act, so it regulated, we talked about the Clean Air Act, but one of the things that the Clean Air Act did was regulated the use of lead, especially in lead fuels, and that decreased the amount of atmospheric lead that was present in the atmosphere. But another thing they did is they established the 6 criteria air pollutants and established recommended guidelines. And another thing was a cap and trade of sulfur dioxide. And this is kind of like, so imagine, I put this graphic here, but you have one area, they're given so many allowances, like you're having a pollution credit, like you have so many pollutants you can emit into the atmosphere. And one country might not emit enough, as many pollutants as they anticipated. So they have this unused allowance. And then this other country maybe went over. So what this country would do would sell its unused portion of pollutants to another country. So basically, you're not really, it's not individually limiting each country. Like somebody like the United States or a country like the United States, we're a wealthy country. We could buy unused allowances from other countries. Now the Clean Air Act is a United States law, so this is capping and trading sulfur dioxide amongst different companies and or states. But when we have any international agreements, first of all, you have to assume that everyone is going to be buying into it. And if somebody doesn't buy into it, then it really is not as effective. But that's what cap and trade really is about. Again, the Clean Air Act was focusing on getting rid of lead. And that happened in the 1970s. And you'll notice that the atmospheric lead rate or atmospheric lead concentrations have decreased steadily since then. Other ones you could do is you can conserve the source of the pollutants. If you're using less of the source, you could drive less. You could maintain your car so it runs more efficiently. You can also carpool or take public transportation. Another thing to eliminate the air pollutants, there's a lot that are associated with agriculture. So if we have a more plant-based diet, you would eliminate anything that is associated with consuming meat. So anything with monocropping, all of that would be eliminated. You would lower the fossil fuel use, and there would be fewer fertilizers. Remember that fertilizers are contributing to the nitrogen cycle, contributing to eutrophication, but it's also adding nitrous oxide, or N2O, to the atmosphere, which is a greenhouse gas. And finally, we can look into alternative fuels. So if we have alternative fuels or energy sources, we'll reduce the amount of carbon dioxide, NOx, SO2, sulfur dioxide, mercury, particulates. All of those will be reduced if we switch to like wind energy, hydroelectric, geothermal, solar, or having a fuel cell in a car. So a car that operates on hydrogen, which has problems with the implementation on a large scale. So other methods, and these are methods that can be done in different settings, but one thing that you can do, and you see this little, like, if you've ever filled up a gas tank, there's this little tiny little, like, looks like a upside down funnel, but this is a vapor recovery nozzle. And what it does is it fits snugly over your gas tank, so it prevents fumes from escaping. And the amount of fumes that you probably are smelling when you fill up the gas is a lot less than you would be smelling if you didn't have that. So there are still some escaping, but it's minimizing the amount that are escaping. And typically the hydrocarbons are escaping because gas is made up of a lot of different hydrocarbons. And benzene is present in gas, and that is a known carcinogen. Remember, carcinogen means cancer-causing agent. Another thing you can do is install a catalytic converter. And actually, catalytic converters were mandated since the 70s for internal combustion engines. So internal combustion engines produce a lot of carbon monoxide. They produce a lot of these hydrocarbons. This represents a hydrocarbon. And produces a lot of nitrogen dioxides. Now, what a catalytic converter does is it will convert things. Like, for example, this carbon monoxide is converted to carbon dioxide. The hydrocarbons are converted to water and carbon dioxide. The nitrogen dioxide is converted to nitrogen gas. Now there are still air pollutants that are coming out with the catalytic converter. It's not 100% effective, but it is way more effective than allowing these to be emitted in the normal amounts. So it is greatly reducing the amount of air pollutants that is coming from internal combustion engines. Is it perfect? No, but it's better than nothing. Another thing you can use, this is for coal-fired power plants, is use something called a scrubber. Now there's differences between wet scrubber, dry scrubber. I'm simplifying this for our purposes because they don't really require you to go into too much detail, but you have to understand a little bit of the concept. So for a scrubber, you have it's called the flue gas, and basically what that means is that's just the gas exhaust from the coal-fired power plant. So this is the gas with all the soot. That's why it's brown. Now what you have, this is an example of a wet scrubber. You basically drip water down or spray water down, which then will kind of collect. It will take a lot of the impurities out of this smoke, this soot, this gas, and it will collect in like dirty water at the bottom. And that can be collected and disposed of properly, whether it is put in a landfill or it is treated in another way. But now you have all of this dirty water coming out the bottom, but you should have theoretically clean or cleaner gas with a lot fewer pollutants. An electrostatic precipitator, first of all, basically what it is, it's metal plates and you're running some sort of gas through that, and you need to have an electrical charge, and then the particles are going to clump together. They're going to coalesce and clump together and basically accumulate on these metal plates. And then all you have to do is literally wipe the metal plates down, and it will greatly reduce the amount of particulate matter. Now, I have seen these present in home air purifiers. There are electrostatic precipitators, which basically the air runs through it, and little dust, little tiny particulate matter will get stuck to it because it's negatively charged. And these metal plates are positively charged. So what happens is opposites attract. All of these pollutants will collect on there, and then you can wipe it off and dispose of the pollutants. It's much easier to dispose of the pollutants when they're in solid form or when they are contained, as opposed to when they are airborne. Fluidized bed combustion. Now, this is just a fancy way of saying you're burning coal with calcium carbonate or limestone. And what's happening is the calcium carbonate is absorbing the sulfur dioxide, and it will produce calcium sulfate. Calcium sulfate is used to make gypsum, or as a main component of gypsum, which is a mineral. And gypsum is used in sheetrock. You know that white, like when you break the sheetrock, it's like chalky kind of powder. It also is used in like chalk for blackboards. So sidewalk chalk also will have gypsum. So we can basically recycle the gypsum and use it for other purposes. Another one would be a baghouse filter. And this is used in coal-fired power plants, and it will remove the particulate matter. So the particulate matter is then disposed of in a landfill. Okay. Now, big takeaways from this is baghouse filter removes particulate matter. Your fluidized bed combustion will remove your sulfur dioxide, and electrostatic precipitate will also remove particulate matter, and the scrubber will remove a lot of the impurities, including the sulfur dioxide, from a coal-fired power plant. For your FRQ practice, I would like you to examine the graph, which shows the mileage, the fuel efficiency, or the fuel economy of commercial vehicles, and you have your NOx emissions over time. I would like you to explain the trend shown in the graph to the left. Thank you for your attention. I hope this was informative. I will see you soon.